Welcome back to Algebra 2. Today we'll be discussing our fourth section in quadratic functions, and our fourth section is on complex numbers. This is a brand new topic for us. So complex numbers. It is also known as an imaginary number, and it is represented by the letter I. I is defined as I squared is equal to -1. So let's look at that a little closer. If I squared equals -1, first off, how would we get the I alone? Because this is I squared. Well, we would take the square root of it. If we take the square root of it, I is being represented then as the square root of -1. Okay? So anytime we see the square root of -1 or the square root of a negative number, we just write it as I. So I is the square root of -1, or we just write that as I. I squared, by definition, is defined as -1. So what would I to the third power be? Well, using our products, I to the third power, we could break up to I squared times I. And I squared is just -1, so this is like -1 times I, or just -I. So I to the third power is equal to -I. Let's do the same thing with I to the fourth power. I to the fourth power, we could break up to I squared times I squared. I squared is -1, so it's like having -1 times -1, which we know is +1. So I to the fourth is +1. Let's look at I to the fifth. Well, I to the fifth we could break up as I to the fourth times I. I to the fourth is +1, so this is +1 times I, so I to the fifth is I. And from here, this pattern is going to restart every fourth exponent. So I is I squared is -1, I to the third is -I to the fourth is 1. Then it restarts. So I to the fifth is I to the sixth would be -1, I to the seventh would be -I, and I to the eighth would be 1. So imaginary or complex numbers has a very unique pattern to it, and every four exponents, it keeps repeating itself. So what we're going to do first here is we're just going to do some simplifying. So first problem that we're going to simplify is the square root of -27. First off, before today, we would have all said this is not possible. However, because of this negative square root, we now know we can write it as I. So we know that we have an I in here. But the square root of 27 we can break down. So what perfect square goes into 27? Well, 9 does. So this is the same thing as the square root of 9 times the square root of 3. Well, the square root of 9 is 3. Square root of 3 we don't know, so we leave it alone. And we had the square root of a negative, so that gave us our I. So we say we have 3I square root of 3. Breaking down these radicals, you hopefully remember doing this in both Algebra 1 and Geometry. Okay, 216, the square root of -216. So first off, we know because of this negative, we're going to have an I. But then 216, we have to think, is there a perfect square that fits into 216? Well, yes, there is. 36 times 6. So this is the square root of 36 times the square root of 6. The square root of 36 is 6. And the square root of 6 we don't know, so we leave it alone. So this is 6I square root of 6. Simplified down. All right, we'll do one more like this. Square root of -18. So we know the negative sign here definitely gives us an I. And then 18, it has a perfect square of 9. So this is the square root of 9 times the square root of 2. Square root of 9 is really 3. Square root of 2 we don't know, so we leave it alone. So this is 3I square root of 2. The key here when you are breaking these down is you must find the perfect square that's a factor. If you don't have a perfect square that's a factor of the number, then you're not going to be able to break it down at all. Okay. Okay, so next one, we have negative 5i times 3i. Well, when we multiply these, it's just like dealing with x's. So we take negative 5 times 3, which is negative 15. I times I would be I squared. But we know that I is I squared is negative 1, I to the third is negative I, and I to the fourth is positive 1. So we know that I squared is equal to negative 1. So instead of writing I squared here, we're going to write negative 1. Negative 15 times negative 1 is a positive 15. So that simplifies down to a positive 15. Next example. It's negative square root of 6 times negative square root of 15. First off, this is a square root of a negative, so that's an I. Square root of negative, so that's an I. Square root of 6, we actually can't simplify down any further, so we'll leave it square root of 6. Square root of 15, also there are no perfect squares, so square root of 15. Well, I times I is I squared. 6 times 15 is 90, so this is I squared times the square root of 90. Now 90 does have a perfect square of 9. So square root of 9 times the square root of 10. Square root of 9 is 3, so it's 3 square root of 10. And then once again, we know I squared is negative 1, so we replace this I squared with negative 1 times the square root of 90 simplified down to 3 square root of 10. So this is negative 3 times the square root of 10. Next problem, simplify. This says 5 minus 7i plus 2 plus 4i. So when we have this plus sign here, we just want to combine our like terms. So 5 plus 2 is 7. Negative 4i, or negative 7i plus 4i is a negative 3i. So this is just 7 minus 3i. All right, so this next one, simplify. 4 minus 8i minus 3 minus 6i. Minus, so we're just going to combine like terms. So first off, I would suggest to change the opposite throughout. So we'll change it to plusing a negative 3 plus a 6i. And then 4 plus negative 3 is 1. Negative 8i plus 6i is minus 2i. So simplified. All right, and now we'll do 2 examples on solving. So to solve these, we want to get the x alone, because there's no way we can factor this, because this is currently a sum of squares, and there is no formula for that. So we're just going to get our x alone. So we'd subtract 64. So we have x squared is equal to negative 64. You get rid of a square by taking the square root of both sides. So x is equal to, well, the negative part of this makes it an I. 64, square root of 64 is 8. And when we are solving, this could be a plus or minus 8. So we'd say plus or minus 8i. It can be a plus or minus because if we take a negative 8 times a negative 8, we would have got a positive 64. Same way as if we took a positive 8 times a positive 8, we would have got a positive 64. So there were 2 ways to get your positive 64 here, by both using positive 8s and negative 8s. So anytime we solve and take the square root of our answer on both sides, it's always going to be plus or minus. All right, and one more solving one, get the x alone. So we'll start off by subtracting 100. So we have 4x squared equals negative 100. Divide by 4. So x squared is negative 25. And we take the square root. The negative sign is I. Square root of 25 is 5. And since we took the square root of both sides, we say plus or minus 5i. So there we solved it. We will be doing a part 2 of complex numbers tomorrow.